Hello everyone, welcome to Infinite Works. Let us discuss about resolution of vectors. By definition, it is a method of finding the effect of given vector in the desired direction, or simply it is a method of finding the components for a given vector. Let us try to understand this in much better way. Suppose, say here A is the given vector and this vector A will be having its effect in every possible direction, that is along A1, A2, A3, A4 and so on. Not only along these directions, this vector will be having its effect in every possible direction, but the maximum effect will be in the given direction, that is along this direction. So I have highlighted this one here, and now this vector can be resolved into infinitely many components. But for our convenience, we are going to resolve this vector into two perpendicular components called orthogonal components or rectangular components. That is, we are going to find the effect of this vector A along these two perpendicular directions. Now before getting into resolving the vectors, let's have a look at the trigonometric ratios. Now I am going to explain how to identify the sides of the given right angle triangle. Suppose consider this right angle triangle and let theta be the one of the interior angle here, and now in any right angle triangle, the side opposite to the angle theta, I mean this side, will be the opposite side, and the side opposite to right angle, that is this side, will be the hypotenuse, and the remaining side would be the adjacent. Similarly, consider this right angle triangle. Here theta is the angle here, the side opposite to the angle theta, that is this side, is the opposite side, and the side opposite to right angle, that is this side, is the hypotenuse, and the remaining side is the adjacent. Now by trigonometric definitions of right angle triangle, we have sin theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite side over adjacent side. Now consider vector A representing both by magnitude and direction. Here the arrow mark indicates the direction of the given vector, and let the origin of this vector coincide with the origin of xy coordinate system, and CB and CD are the two perpendiculars drawn to x and y axis respectively. Let theta be the angle made by vector A with respect to its horizontal component, and here AX is the component of vector A along horizontal axis, that is x axis, and AY is the component of vector A along vertical axis, that is y axis. That is, these two are horizontal component and vertical component. Now consider this right angle triangle OCB. By definition, we have cos theta equals OB over OC, that is adjacent side over hypotenuse side. So we have here AX over A. Similarly, in this right angle triangle for sin theta, we have opposite side over hypotenuse, that is CB over OC, and you can observe here CB is same as OD, so CB is replaced with OD, and for sin theta finally we have vector AY over A. Now solving for AX and AY, we get A cos theta and A sin theta. These are the values for two perpendicular components for a given vector, and not only for perpendicular components, we can find the effect of given vector, or we can resolve the given vector into infinitely many components. Suppose, say A is the given vector, and if we want to find the effect of this vector A, say along this direction, let theta be the angle made by vector A with respect to one of its component. Now the effect of this vector A along this direction is given by the formula A cos theta, and this is the general formula to find the effect of given vector in any direction. Now let's verify this formula with the perpendicular components. Say here, let A be the vector, and this is the horizontal component and this is the vertical one. Let theta be the angle made by vector A along with the horizontal component. Now by this formula we have here the effect of this vector A along this direction is given by A cos theta, and if this is theta, this will become 90 minus theta, and the effect of this vector A along the vertical direction is given by A cos of 90 minus theta, because theta here is 90 minus theta. Now by the complementary angle definition, we have cos 90 minus theta equals to sin theta, and finally for vertical component we have here A cos of 90 minus theta equals to A sin theta. In general, the component to which the angle is linked will be the cos theta, and the other component will be the sin theta. In previous step also, here theta was the angle made by vector A along with the horizontal component. Suppose if the theta was the angle made along with the vertical component, then this component would be the cos theta and this would be the sin theta. You can verify this once. And this is about the resolution of vectors. And friends, this is my new channel and also my first video. Do subscribe if the video was helpful, and thank you for watching.